Okay, so in this question, so if you're reflecting a 2 by 2 matrix across a line, and let's say line is y equal to mx, m is the slope of this line, then the corresponding matrix can be computed using this. So it's 1 over 1 plus m squared, 1 minus m squared. This is 2m, and m squared minus 1. So I'm not going to really get into the proof of this, but if you have a 2 by 2 matrix that reflects vector in R squared across such a line, then the matrix has always this form. So I guess we can just take this and use it. So our line is this: y equals -4 times x, right? So then m is -4. So I'm just going to take that and plug it in here. When I do that, this will be 1 over 17, and this will be -15. This is -8. This is -8, and this is +15. Okay. Now the eigenvalues of this matrix. I mean, it's given, so we're only finding the. I mean, if you look at the eigenvalue of this matrix, is ±1, but we're only looking for eigenvectors corresponding to this eigenvalue. So that's what I will just do. So, but the eigenvalues are plus and minus 1 of this matrix if you compute it. So I'm just going to do this: a minus lambda times identity, and lambda is -1 here, so this is actually just a plus identity. So this will turn into this. So if you do that, you will get negative. So this is that matrix 17, and this is 8 over 17, and then this is 15 over 17. So you're adding identity here, which is 1 0 0 1, and that will be, so that will turn this into 2 over 17, -8 over 17, -8 over 17, and if you add a 1 here, that's 32 over. Okay, now I'm just kind of reducing this. So I guess I can just reduce this matrix by multiplying top by 4 and add it to the bottom one. So when I do that, it's just going to make this 2 over 17, -8 over 17, and this will all be 0. And then I can just scale the top one by, okay, I can multiply by 17, 17 is gone, and I can multiply by 2, so this will turn into 1 -4 0 0. And if I rewrite this system, this will be x1 equal to 4x2, where x2 is free. So x2 is a free variable. Then I'll have this matrix. So 4x2, 1. I mean, this is x2. Then this will be x2 times 4 and 1. Any multiple of 4 and 1 is going to be an eigenvector. So if you look at those choices that are in the problem, just look for any multiple of 1. Any multiple of 1 is going to be an eigenvector. For instance, I see 4 and 1 there, and that's the only one. I think that's the fourth choice. 1, 2, yeah, that's the fourth choice. So fourth choice is the one that we're looking for. So 4 1 will be, because there is no other scaling in the other choices, so it's just 4 and 1. Okay, so basically the key point is the matrix, right? And the matrix has this form that I put it over here, so you can always use that when you're reflecting across a line.